Hi guys! Today I'm into microcontrollers. Specifically, I want to write a simple Hello World program in the programming language C. This is the first time I use an ATtiny 85. That's the datasheet of the Atmel ATtiny. Here is a quick overlook of the features. I really like that the part has a wide operating voltage range, which is from 2.7 volts up to 5.5 volts for the normal parts, which I use. And also the current consumption, which multiplies to the power consumption, of course, is also pretty low. Let's see, they have a chart in here. Oh, there it is. Yeah, this chart shows the active supply current depending on the operating voltage and the frequency. And as you see here, so voltage of 3.3 volts brings at 1 megahertz clock frequency a current of nearly 0.6 milliamps. So that's pretty good. Let's see how the higher clock frequencies are doing. So we take also the 3.3. This is what I use on a regular basis. And on the standard internal RC clock frequency, we have a current of, it's about 3 point something milliamps. That's okay. And if I use the 16 megahertz PLL clock, the graph ends here. But it's probably here at, next quite 6 milliamps. I don't know. Yeah, here you see the pins, or the pin configuration of the Tiny 85. I use it in the 8-pin DIP package. And you see we have VCC and GND on 8 and 4. And okay, the rest pins go to the port B, and all pins have of course different functionalities depending on the configuration you do. I don't want to go too much into details right now because that might be not too interesting for you, but look into the datasheet is well worth the time. For coding, I use Programmer's Notepad, which is a free software by Simon Steele. It's available on the net. It's a neat tool. It contains various functions to make life easier for a coder. In the first 2 lines of the code, I include definitions for the inputs and outputs, as well as the routines which are necessary for the delay command. Here I define the frequency of the clock, which is essential for the delay calculations. Inside of the main routine, I placed the DDRB command. That's the Data Direction Register Port B command. The value OXFF represents the hex value FF. In binary format, this equals to 4 ones and 4 more ones, so that's 8 ones. So all applicable pins are outputs because 1 equals output on Atmels. And you can see it here. The calculator of Windows is really useful when you switch to the programmer mode, and there you see it, hex FF equals to 8 ones and decimal 255. I also placed a while loop which repeats all included commands over and over again. In the loop I turn on the LED by setting pin BO to 1. The MCU waits for 1000 milliseconds, which is 1 second. I turn off the LED by setting BO to O. As you can see here, instead of a 1, we have a O here. The MCU waits again for 1000 milliseconds, and then the cycle repeats over and over again. For compiling, I use Atmel Studio 7, which is available from microchip.com. It's a legacy software because Microchip acquired Atmel on the 19th of January 2016, but the tool is still useful because it is easy to use. So that's the code here, and now I have to compile it. There you see, it compiled with no errors. That's good. Now the code needs to be flashed into the ATtiny 85. For this, a hardware programmer is needed. I use the USB ASP. The blueprints are released on the GNU GPL, so it's possible to build it as a DIY project, but finished PCBs are cheap to buy on the net. Here you see it. I have built my own adapter because I like single inline connectors. To use the USB ASP, I use the software proc-ISP172. It's available on the net. First I select the correct MCU model, which is the ATtiny 85 of course. Then I use the RD button, which stands for read, to read the ID. So as you see, the ID have been read successfully. I read the ID of the MCU to check for correct data transfer. I activate chip erase, program flash, verify flash, and program fuse. Then I open the fuse setting by clicking on the hex number in the line of the program fuse and change only the clock setting to PLL clock. So everything stays the same except for PLL clock. And you can see that the fuse setting was ending with 6.2 before and now ends with 6.1. So that's the change. Then I have to load the flash file, which is the hex file you see here. And then, if everything is checked OK, I can click on the Auto button. And as you see, erase, white flash, verify flash, write fuse have been done successfully. So now the microcontroller is programmed and I can test it out. Hooray! The LED flashes and says hello world. I'm really happy that this test works so successfully, as the clock relies on a simple RC oscillator, which consists of a resistor and a capacitor, as the timing parts of the frequency can be a bit off. In timing critical application, this can be an issue. I probably try to measure and calibrate the clock of the ATtiny for an improved performance. Please donate to help me out of trouble. My PayPal address is donatesurfloose@gmx.net. Any help is appreciated. If you're not already a valued subscriber, you now have the chance to become one. Like, comment your thoughts, and stay tuned for more videos. I will see you next time. Bye bye.